In this problem, we're asked to calculate the activation energy given the values of the rate constants at two different temperatures. So this is clearly going to be the equation that we need to use because it shows the relationship between those two rate constants at different temperatures. Now, the information that we're given is given in Kelvin, which is fine. That's the temperature unit we need. And the two rate constants are given in the same unit, so we can take their ratio quite easily. So let's set this up. We're going to have log of the two rate constants, and I'll use this one as K1 and this one as K2. So we'll have 0.018 minutes to the -1 divided by 0.25 minutes to the -1. And that's going to be equal to negative of the activation energy, which is the quantity that we want to calculate, divided by R, 8.314 in joules per mole Kelvin, and then two temperatures. Now here we want to be sure 300 K is associated with this value of K, so this is T1 and this is T2. So I'll have 1 over 300 K minus 1 over 500 K. All right, when I calculate the logarithm of this ratio, what I'll come up with is -2.631. Okay, and we should always check to make sure that that number makes sense. This number is a number less than 1, so the logarithm of it must, number less than 1, so the logarithm of it must be a negative number, and that's what we do get. All right, this is going to be equal to negative of the activation energy over 8.314 joules per mole, and I'm going to get rid of the kelvins because they all cancel. And this pair of numbers, when combined with the 8.314, is going to give us a result that looks like the activation energy times 1.604 times 10 to the -4. Now, what are the units of this? Well, it's in 1 over joules per mole. So I'll have moles per joule, if you will. Okay, so now how do we undo this? Well, we've got minus signs on both sides, so we can kill that. We can divide both of these by 1.604 times 10 to the -4 moles per joule. And we divide this by 1.604 times 10 to the -4 moles per joule. Now notice, since this unit is in the denominator, it's going to flip around when we make this division. And when we calculate this out, we'll find that the activation energy now is going to be this number, this ratio, which is 16,400 in units of joules per mole. And if we want to write that in kilojoules per mole, it would be 16.4 kilojoules per mole. And that's the answer for this part of the practice problems.